Welcome to QInsight from QGate, where we explore where CRM, AI, emerging technologies, and the real world meet. I'm Steve Clarke.
And I'm Alastair Jupp. Today we're joined by Jamie Plumridge. Jamie is Channel Director at nLighten, a seasoned technology leader with more than 25 years experience in managing strategic partnerships across the UK and Europe. In this episode, we'll be talking about the hidden infrastructure powering AI, why data centers are becoming one of the industry's biggest battlegrounds, and what happens when demand for AI starts colliding with physical reality.
Jamie, welcome to the show.
Thank you very much for inviting me on. It's a real pleasure.
Well, I, from a personal perspective, I've just got to say, additionally, it is my pleasure to have you on the show because it's your fault I'm sat right here because virtually 20 years ago, you gave me my first sales job. So everyone that I've engaged with ever since solely have you to blame.
So massive apologies, Alastair. I apologize.
Excellent stuff. Excellent. So, Jamie, here on the podcast, we as a business, we focus on CRM and kind of ancillary offerings around that. More recently, as we're all very aware, AI has been front and center of most conversations. But what we found is these conversations typically focus on things like software, apps, and the tools that you can use under the banner of AI. But in your world, it actually starts with something very much more physical. Why, and this is how we're going to open this show up, I'm going to ask you the question, why do we need to remember that actually the cloud has to still exist somewhere?
Frankly, because it does. and always has done. Look, the cloud is not some mythical place. It has always been a physical infrastructure reality. And that reality continues today. The cloud has to exist physically somewhere, but AI is really accelerating that reality because of the nature of the requirements that AI infrastructure have. And I'm sure we'll go into that in a little bit more detail, but the physical reality of the cloud, whether it's running AI workloads or whether it's running traditional enterprise workloads, is a reality that's impossible to ignore. It runs on hardware in a building, and that hardware needs power, and it needs cooling, and it needs space, and it needs security. Things are changing pretty rapidly in terms of what we would consider classic enterprise cloud to now what we're really looking at from an AI infrastructure perspective. But the fundamentals are there. The cloud is a physical space with physical needs.
There's always an operating system an operating model actually, but underneath every tool you use, right? And I think AI has really pushed things right the way down to kind of chips and, as you say, power, cooling, and I think it's actually made infrastructure interesting again, right? It really has. It brought it right to the surface, hasn't it? It's much more aware of it.
Yeah. It certainly made our industry kind of sexy again, which is great. Look. When we turn on a light bulb, right, we don't actually think about the infrastructure that sits behind the process of that light bulb turning on. That ultimately there is a power station that sits behind that magic of that light bulb turning on in our house. Now, as users, of course, naturally and perfectly understandably, we don't concern ourselves too much with that, and that's fine, but it doesn't take away the importance of the underlying infrastructure that actually enables that technology. Mobile phones, they're just lovely shiny bricks, really, with a nice screen on, unless you have an underlying cellular infrastructure that's actually making that device useful for the user. And AI is no different. AI is a lovely feature, But it really doesn't do anything unless you have the underlying infrastructure to make it work.
Came across a stat the other day, actually in my research for this, because infrastructure is actually way outside my comfort zone, actually. So, so I did some research into this, and it said data centers used roughly 415 terawatt hours, I think, of electricity in 2024, about 1.5% of the world's total. And the IAEA expects that to roughly double to 945 terawatt hours by 2030. And that's slightly more than the Japan's entire electricity use.
Yeah, great stat and absolutely true. Look, data was always increasing and growing exponentially year on year, even before AI really came into our consciousness. With the advent of AI, the amount of data that we're producing and consuming has been accelerated 100-fold. And that data has to sit somewhere, and that infrastructure that is holding that data has to have power and cooling. Great. I mean, the average hyperscale facility, Alastair, to throw a stat right back at you, the average hyperscaler data center facility. So I'm talking about a Google or a Microsoft now. So these large, centralized, massive, multiple football field size data centers that sit in Arizona somewhere or wherever. They now consume about 100 to 200 megawatts of power, and that's enough to power a small city. So, to put it in context.
So and we were always going to touch on how AI had impacted data centers and that requirement for everything around physical space, power, security, whatever that might look like. But are we prepared as a civilization? And that's a really quite a statement. Like, are we prepared to deal with this? Because we all know AI isn't going anywhere, at least for the time being. So when we talk about the increases that Alastair alluded to in those stats a moment ago, are we going to run out? Are we going to run out of AI and make it sound like a consumable commodity? Could we, for all intents and purposes, just get to a point where we're creaking at the seams? Could that happen?
Yes, that is a possibility, unless we change and a collective how we are powering this particular technology. Look, if you look at NVIDIA, who are the primary GPU manufacturer driving AI technology, they're really moving faster. I mean, they're unbelievably talented, unbelievably impressive organization, but they're really moving from a GPU development, which is what runs AI models. They're moving faster than the infrastructure can support. Our infrastructure globally was really designed for classic enterprise workloads. So, racks of servers and storage and networking probably consuming an average per rack of about 5 to 7 kilowatts of power. And the whole infrastructure, including data centers, by the way, were really built on that requirement over the last few decades. Now with, the latest NVIDIA chips, just one rack, pushes over 200 kilowatts of power just required to power one rack. And in a GPU cluster, to make it a useful, large-scale, general-purpose AI GPU cluster, you really need hundreds of these things running. So, the problem is real, Steve. You're absolutely right, and it's an issue that is discussed in my area of the industry all the time. How do we keep up with this requirement from this new wave of technology?
So you've calmed my concerns there. I was getting a little bit worried my co-pilot was going to stop working this afternoon.
I think you're okay on that for now.
Yeah. God, can you imagine a world without a co-pilot now?
Can I ask a tangential? I'll probably get told off for this afterwards, but why did they build a data center in the middle of Arizona, which is quite a hot state, isn't it? Why would they not build it in Alaska? Just curious, to be honest.
Well, I mean, the answer is that they are looking to build data centers in Alaska. Look, some of these data centers were pre-existing the AI GPU wave, and they've been repurposed. There's space availability in these areas, which these data centers require huge amounts of space, particularly the hyperscale data centers. There's available power often, particularly if you look at renewable power in places such as Arizona. You have an abundance of wind and sun power in particular. But the cooling aspect is a real issue, Alastair. Yeah. So, we don't cool these AI GPU racks with air anymore. So we used to, basically suck out the warm air and disperse it to be simplified with it. We can't do that now because of the sheer amount of heat that is generated by these GPUs. They would literally melt. So now we have closed loop, what we call direct liquid cooling. So there's actual liquid cooling loops that directly pump around the whole racks. Liquid removes heat better than air, and that's what we use now to be able to cool the massive amounts of heat that are coming off of these GPUs. So as long as you get your direct liquid cooling technology correct, then in theory, again, simplifying, but in theory, it doesn't really matter how hot it is outside because it's a closed loop direct liquid cooling. But that said, in places like the Nordics, where you again have an abundance of renewable energy and you have natural cooling, the data centers become more efficient because you need to remove less heat, and that's why data centers in the Nordics, we've just opened one in Sweden, tend to be cheaper energy, cheaper running costs because it's more efficient with the cooling.
What's the global impact of stuff like this? Because we hear about net zero, carbon emissions, all that good stuff, which sustainability, which actually we all need to be very cognizant of. But I mean, for your organization, I think surely there has to be regulations around the output, because if we're talking about all this heat generated, surely that has to go somewhere. Is there any benefit from that? Can you start doing useful stuff with the output, the waste products?
Yeah, again, it's a massive topic of conversation for our industry. We do, as an industry, require a lot of power, and we have a lot of wasted heat potentially, and that's not particularly sustainable. But the industry as a whole, and I have to say, nLighten have very much been leading the way on this. We are putting in place technology and projects to be as sustainable as possible. For instance, at nLighten, instead of the heat being from the data center being completely wasted, we have live projects in place right now. We have particularly one in Germany, which has been running for 2-3 years now, where we actually capture the waste heat, and that heat gets pumped out through a district heating pipe to heat the local council offices and the local outdoor swimming pool. Okay. We are just, I don't know how much I can say on this, but yeah, there will be a new project in the UK fairly soon where the waste heat will go out to contribute to the heating of about 300 new build homes. actually.
Excellent.
So the data center starts to integrate into the district heating. But there's other things that we do. So we only use true 100% time-stamped green energy. We do that by having massive industrial batteries on site in the data center. So there isn't always, you can't always get green energy in live time because it's not always windy, it's not always sunny, it's, you know, the water is not always flowing, etc., etc. So the grid can't provide 100% green energy all the time. But what we do when there's an excess of green energy available from the grid, we actually take more than we require and we store that in these massive batteries on site in the data center. And then that enables us to do two things: utilize that energy, that green energy, when there isn't enough from the grid for our own use. And secondly, when the grid has an over demand and under supply of green energy, we actually pump that energy back to the grid to contribute. So I think data centers will become increasingly part of sustainable initiatives, and we're very passionate about that.
Absolutely. So bringing this back to AI and the types of organizations that we here at QGate engage with, typically we operate in the kind of SMB mid-market space, and to the companies, the business leaders that we speak to, AI normally means one thing to these types of organizations: Copilot or ChatGPT. We're looking at improving efficiency around sending emails or automating some tasks. And I'm oversimplifying, of course, but in your world, when we're talking about NVIDIA GPUs and megawatts of power consumption, to organizations that need that kind of infrastructure, AI is a different prospect. We're not talking about user licenses to get into something. What are these businesses doing? I mean, why do you think that they need that kind of infrastructure? What are they doing compared to what maybe organizations that we would normally engage with using AI? How does that differ?
Yeah, look, I mean, I'll probably address that in two ways: from an AI provider perspective,
Yeah.
and like an AI consumer
Mm.
perspective in the business world. So typically, our customers that come into our data centers are in the business of providing AI models at scale out to a wider market. So they can be GPU as a service providers, for instance, neo clouds. So, and they're effectively doing two things. So there's two types of AI stages going on, and I liken it to going to school or college and university. So that's what we call LLM. So this is large language models. This is where you're training the AI model to understand of what it's going to do as a job eventually. Now that requires huge amounts of GPUs. It requires huge amounts of power. These typically sit in very large hyperscale type data centers. Then you have the second stage, which is far more important, really. It's called AI inferencing, and the AI inferencing means you've been to school, you've been to college, you've been to university, you've learned about all this. We've molded your brain. Now go out into the world and do the job. So that's for a customer like for nLighten, that is really the typical type of customer, because we have edge regional data centers. You have to take that brain out to closer to the user where it's actually being used. If I can answer the question from an end user perspective, I think there's a huge gap right now between your large public organizations, particularly in regulated industries that are really invested in large scale AI deployments, either via a partner or directly, and they're training those models very specifically on their business processes, their workloads, right? And it's very important to them that they have data sovereignty, so they know where that data is. It's ring fenced, very sensitive information, so they know that data is not going outside of their sphere of control. And then, I think there's a big gap between that and then, the SMB market, for instance, or even the mid-market to a degree, is still really consuming AI as a feature through products that have AI integrated into them. So a little bit more superficial in terms of how it's actually used and deployed across the organization. But we see that gap will close over the next couple of years.
I mean, at the moment, no SMB is going to outbuild a hyperscaler, right? It's just not. They don't need to, right? The real question is, how do they access AI capability that's secure, affordable, and obviously useful?
Yeah, I think the barrier to entry at the moment to building your own AI models and utilizing your own AI models on your specific data, your specific business processes, is probably too high, really, to justify the business case for an SMB today, particularly if you're not in a regulated industry. And why would you today? Because there's plenty of products out there. We're really at the start of this revolution, and I do call it a revolution because in my sort of 25, 30 years in the technology industry, I've really seen primarily two previous revolutions, which was, the internet really becoming regularly used in everybody's lives and in our business lives in particular. And then the second one was, mobile phones. I think the AI revolution will eclipse both. And we're really at the start of that. And very naturally, SMBs don't have the in-house skill sets. They don't have the access to vast amounts of investment. I mean, one NVIDIA GPU costs somewhere between $25,000 and $40,000, and you need hundreds of them to make it. And that's just the purchase of the GPUs. Then you've got the energy costs to power it. You've got the cooling that you need to put in place. You have to have you can't just put it in a cupboard in your office anymore because it would melt. So you have to go to a dedicated data center space. Then you've got the physical security side. I mean, you've got millions and millions of dollars of infrastructure sat in these data centers. You need a 24/7 security. And then there's the whole redundancy aspect. So, that's very expensive to have a whole bunch of GPU clusters sat there doing nothing because the power's gone down. So you need environments where you have redundant power generators on site, all these things. So at the moment, I just think it's not, SMBs aren't really doing it yet, but we do believe that over the next couple of years, that market will really start going deeper in deploying AI across their businesses. Because if they don't, their competitors will, frankly, and they'll fall far behind. There's massive productivity gains from really integrating AI into your business. But as I said, I think that's probably a couple of years away, and they'll probably consume it via MSPs.
Now this raises an interesting point, Jamie. And actually, one thing on this podcast that we like to provide things like, along with insight, is practical tips. Now, from an insight perspective, we were very keen to get you on the show because you are exposed to practices, technological advances that maybe we're not, because you do deal in that enterprise space with enterprise clients. So, and it is, as we see virtually exclusively, when something new comes to market, it is the big organizations that can fund the R&D and start doing the do before it trickles down to the mid-market and enterprise. Now, talking about kind of closed AI models, we had a guest, Vincent Slider, on the show last season, and a great proponent of AI. Has been working in it regularly for a long time now, and he actually built a closed AI model utilizing, I think, 4 MacBooks. So,
Yeah.
and he kind of hypothesized and then actually went through to proving the fact that actually, if you link all this processor power together, you can do it on a small scale, but nevertheless, a scale that could be used in regulated industries. Because yes, absolutely, as much as we do like to trust the terms and conditions that attach to every single one of these AI platforms that we use, when you're talking heavily regulated, you just can't do it.
Yeah.
Going back to the point a moment ago about MSPs, do you think then it's going to be almost like a SaaS model? I'm trying to think, not necessarily a SaaS model, but there we go, a subscription model. Do you think it could be almost AI on a monthly basis, something along those lines? Is that how it's going to be first achieved by the SMB and mid-market space?
Yes, I mean, and it already is,
Mhm.
albeit at this point in time, a relatively smallish part of the market that, that already exists. It's going to be consumed much in the same way as managed service providers have provided cloud services for the last couple of decades.
Mhm.
Um, you know, Local MSPs will have a GPU cluster, obviously of a more modest size than the large language models, but still, you know, uh, sizable and with a lot of performance capability. And they will use that GPU cluster to deliver AI as a service out to a regional market. And we are seeing that already, and I
Mhm.
think we believe that that is the next wave of how SMBs will consume AI, so that they can start to actually deploy AI for real workloads that are specific to them and their businesses. Um, in terms of linking 4 or 5 MacBooks, laptops, or desktops together to run a closed loop AI model, it's absolutely possible. 100% it is, but it's not very efficient and it's not very scalable. So you can use that. CPUs and GPUs are, in many ways, if you really boil it down to its basic level, they're doing the same thing, processing data.
Mhm.
The difference with GPUs are that they're designed to do that at lightning speed, to
Yeah.
you know to process those prompts and those requests uh,
Mm.
seamlessly between many linked GPUs. So the latency in between is infinitely small. So it acts as one brain. I think
Yeah.
where you've got different CPUs, you could do some basic models, document classification, that type of thing with that model. But if
Mhm.
you really want to start deploying, multiple parameters, something that's really going to give you deep insight or start delivering a customer service or a sales or marketing outreach, I think you're going to be very limited, because even with those CPUs, actually one of the biggest limiters is actually the latency between the CPUs. And then you've got your constraints of your local network. So if you're running that on Wi-Fi, you know, it's not going to run very, very fast. I mean, these GPU clusters have very, very high bandwidth, specifically designed networking that are attached to them that can transact that data at, you know, speeds that we've never seen before. So I think that's the difference. It's the scale, and it's choosing the right solution for the workload that you're trying to achieve.
Horses for courses.
The catch here, as you say, is the scale, right? A small model solving one defined problem, a very narrow kind of piece of activity, is a completely different animal from a general purpose kind of one serving millions of people. Does that say, we kind of touched on MSPs, is there kind of a gap in the middle there, an opportunity in the middle between these tiny kind of almost on-prem type things and then the massive scale, the MSP sitting in that middle space to sort of the mid, you know, is that likely to, have I understood that right? I mean,
yeah, you're 100% right, Alastair. And as I said, we are seeing that already. You know, there's early movers in the MSP space that are really developing AI as a service already, and some of them sit within our data centers. So you're absolutely right. And look, if you look at the future of AI, what we've actually seen is the classic hub and spoke deployment. Actually, the internet was pretty much designed in the same way. You have your main backbone, and then your networking that goes out to your local nodes that are actually delivering and interacting with data at a local level, and this is no different. I mean, what we've really been seeing by and large is the central hub type deployment, which is primarily for the large language models. But if you're running anything that is remotely latency sensitive, such as, I don't know, I mean, we're seeing autonomous cars and autonomous taxis running around cities now, Internet of Things, you can't have that going back to a hub in Arizona if you're in Leeds. You know, because the latency is too much. And this is where we see this hub and spoke. So you're always going to have those big hyperscale deployments sat in huge hyperscale data centers. But actually, that's then going to be going out to regionally located data centers. Well, geographically first in country, and then regionally. And that's where you start to get the real power of AI really servicing you know, the user in a way that is useful to that user and driving an outcome that is tangible for those users. So MSPs are starting to do that now. I'm channel director, right? So my whole world is partnerships, and I speak to MSPs, large and small, national as well as regional, that are putting in place services around this now.
Yes, I mean, well, I want to go back to talking about hub and spoke. I want to go back to was it the term that used hyperscale, the data centers, the big ones, and the future of these, because and this, when we had a pre-production call, as we always do before the show, to kind of talk about, you know, what's going to be interesting, what's relevant to the listeners that we have. And one thing that you mentioned blew our minds, and I don't say that often.
I know where you're going with this.
You know where I'm going, I don't say that term lightly. Powering these data centers, as we've just been talking about, is going to be an issue, we think, or you think, this is why initiatives are coming in and so on and so forth. But nuclear, and I'm going to say that word and really emphasize it, nuclear.
Yeah.
How does that even come in? And we're not talking about powering data centers from a national nuclear facility. We're not talking about these huge, great reactors that would then send power out to towns, cities, whatever that might look like. How are data center organizations, or organizations that are utilizing data, should I say, how are they even thinking about nuclear for something like this?
Well, we have to. The energy infrastructure was not built to deliver this amount of power just to data centers, frankly, and we're keeping up as an industry, just about. But these GPUs keep increasing exponentially in terms of the power that they require, and that will continue, certainly, I think, over the next 10 years. So we have to think about, well, where's this energy going to come from? I mean, the waiting time to secure brand new energy from the grid now is years, right?
Years.
Years.
Right.
That's the situation that we're already in. I mean,
It takes a little while to build a power station, right?
yeah, well, exactly right, and the demand for it is just huge. So, I mean, nLighten, we're careful with what we have acquired. We've built up a distributed network of 36 data centers across 7 European countries, and we've done that over the last really three or 4 years. And we're in a fortunate situation where, through our acquisition strategy, we have available power and contracts pledged. I mean, in France, it's all mostly nuclear power anyway, at a large scale, right? We're not so lucky here in the UK or in other countries where we have that option. So the industry is as a whole, though, is saying, right, where's all of this going to come from? And small modular reactors, or SMRs, is a real thing. These exist today. In fact, Microsoft is actually running some of these from a place called 3 Mile Island, and is actually running these SMRs already today, and we believe that is probably going to be the future of these small nuclear reactors on site to provide power, because we need to find the extra power.
Yeah.
But B, back to the sustainability issue that we were talking about, nuclear power is clean energy. So that's a really important factor as well. Now, how quickly that becomes a reality at scale across our data center infrastructures, honestly, I don't know the answer to that. But this is happening, and it's real, and it's being deployed at an early stage already, because we have to rethink national energy infrastructure and how we're going to deliver this AI revolution that is not going to stop. It's like a freight train. So yeah.
It kind of tells you how big this has become, right? It is now influencing national energy strategies. But there's a couple of things I wanted. A couple of times you've mentioned security. And when you said security, my default was to go to VPNs and, securing the data. But actually, it's physical security. And if you start putting nuclear in there as well, right,
Absolutely.
Your security becomes even more important. And I think the other thing worth mentioning, there is a tension worth kind of bringing up, which is AI is sold as a productivity engine. but it also drives the demand for power, and as we've already discussed. So it's not free intelligence. It's not what it feels like to us out here using it. It's not free, and so eventually supply and demand is going to have an influence, right?
Yeah, it's not free. It takes vast amounts of money and resources such as energy to actually power AI. But we have to do something, and you're absolutely right about the physical security. I think it was about 18 months ago the government classed data center infrastructure as critical infrastructure. So we have the same protection from the government as national energy infrastructure as a data center industry. And it makes sense, right? I mean, it's surprising to people, but it makes so much sense. Our whole world operates on data, and huge amounts of this data is sat in various data centers around the world. If they were to go down or worse, that is going to affect every single one of us, from our businesses to our day-to-day lives if we can't access that data. So it's a real thing, and it's a real consideration for us when we are spending vast amounts of money on upgrading our data centers to keep up with this next wave of infrastructure requirement. The physical security is a very real concern. And again, I was about to say, and it should be for everyone, but no, I mean, look, that's our world. That's what we do. That's why customers pay us to host their infrastructure in data centers, as well as other companies like us. So leave it to us and don't worry too much.
Absolutely. Just on that kind of vein of consuming power in that particular example, you mentioned things like closed loop liquid cool, and I've probably butchered a phrase there in your industry, so I apologize profusely. But what about water in all this? I assume that's just as a valuable commodity as power in getting all this done. Is that a consideration?
Yeah, I mean, there's different ways to cool racks and data centers. One is air. One is can be water.
Yeah.
We've even seen modular data centers that are actually submerged beneath lakes.
So we're in sci-fi territory now, aren't we?
We don't have any of those, but you can, yeah.
But there's space as well now, isn't there? Isn't there conversations with Elon Musk putting stuff in space?
There is, Alastair, and we're going further down this rabbit hole of science fiction, but it's real. Yeah, data centers being put into space is absolutely a real project.
Wow.
Well, it just goes to show how important this stuff is.
Yeah.
Right. I mean, it's really I'm going to sound really dramatic now, but it's really a civilization thing. It's that next phase of civilization and humankind. But you can use water. Some integrate with like local waterways or local canals and use the water to cool that. But actually, water is not the most efficient liquid for cooling these things. We use a specialized liquid. Don't ask me the name. That's not my forte. But we use a very specialized liquid for our direct liquid cooling loops that is very, very more effective than water at removing and capturing heat.
You're not finding it on an SO4 core.
No. And there's even submerging whole racks into oil. Effectively, that's another way. You submerge the whole thing into these massive vats. Again, we don't do that. We've assessed all of the different types of technology, and that one was not the most efficient from our perspective, as well as presenting different biohazard considerations. So we've gone with direct closed loop liquid cooling. Yeah.
Absolutely fascinating. Brilliant stuff. Jamie, look, we're about out of time on this episode. So I just want to ask maybe a final thought. If there's one thing that businesses may misunderstand, or any kind of common misconceptions about infrastructure behind AI, what would you want them to take away from this episode, from this conversation?
I think, Alastair touched on it. AI isn't free. It's not frictionless. This is a journey for everyone, from users through to chip manufacturers, through to the various partners that deliver these services, and right the way down to us hidden but important data center providers. It's a journey. It will continue to be a journey. And I think for any organization, really, whether they're SMB or not, looking at, okay, what is my investment in AI? I would urge anybody to really think about what's the outcome that you're trying to deliver and in which timescale, because you have to use AI, as a business, whatever size you are, and you will increasingly use AI, whatever size you are, over the next few years. And that ramp up will happen quicker than everybody imagines. I mean, I don't Google anymore, right? I just chat GPT when I need an answer. 18 months ago, that was not part of my life. And that is happening in the business world as well. But it's consider what you need at this particular time in your AI journey. Don't overcomplicate it. If you can use AI as a feature to deliver the outcome that you're looking for today, use AI as a feature to deliver that outcome, but be conscious that your needs are going to evolve and get more complex over the coming 24, 36 months.
I mean, as I said at the beginning, this is kind of outside of my comfort zone, but what I do know is that AI scales at software speed, right? Infrastructure just can't match that ever, right?
No.
And there's a gap there, and from what you're saying, pressure is building, and we still have to bear in mind physics, right? That is the physical other side of things.
There's a lot of clever people that are cleverer than I that are working on these problems at speed as well. And I do think our industry is moving faster than it has ever moved before to address these problems. But NVIDIA moved quicker.
Yeah.
Yeah. I mean, you can also apply this same pace to thinking about people, right? I think it's moving faster than people can keep up as well. So for SMEs, our target market, I think the message is you don't necessarily need to own the infrastructure, but you do need to understand the dependency and the pace. And with all this technology, dependency should be looked at with caution. There's still the millennia-old rule of supply and demand, right? Ultimately, if this gap gets bigger, things get more expensive. So I think that caution is really important.
And we're seeing that already. Yeah. I mean, to order GPUs now, you're looking at 9 to 12 months if you're lucky. So that is, driving up the cost of the GPUs. So it is a real consideration. So luckily, there's lots of ways for businesses to consume AI already, whether that be as a feature or via MSPs or GPU as a service providers. You don't have to go out there and spend 20, 40, 50, 100 million on your own AI infrastructure today.
Change our strategy, Steve.
Yeah, you could have said thousands there and it would have priced us out. Excellent. Jamie, thank you. Alice, over to you.
So, Jamie, thank you for joining us on the show, and thanks to everyone at home for listening. If you enjoyed it, be sure to follow or subscribe. You can find us on Spotify, Apple Podcast, Amazon Music, and YouTube.
Jamie, once again, thank you for joining us. It has been a privilege, so I appreciate it greatly.
Really enjoyed it. Thank you for the invite, and I hope that I've enlightened some people.
Absolutely.
Sorry.
One final plug at the end.
we'll let you get away with that. But we'll be back in a couple of weeks for our final episode of season 3, where we'll be taking a look back at the last 3 seasons and how CRM and AI has evolved in these few short months. QInsight is produced by QGate. To learn more about how we're helping organizations navigate CRM, AI, and emerging technologies, visit qgate.co.uk. Thanks for listening, and we look forward to seeing you next time.